Okay, looks like I can't share screen. Can you make me a co-host?
Ray, did you hear that?
Got it.
Yep, I got it fixed. Go ahead now.
Okay. Think we're good here. Okay, should be able to see the first slide, correct?
Yes.
Okay, very good. All right, good evening or whatever time zone you're in. My name's John Sullivan. My call sign's KG7WFQ, and I'm in Mukilteo, Washington, just north of Seattle. And I am going to be walking through this session with you today. There we go. The topic is signals in emissions. This is section 8 of the question pool. Some of the subtopics we've got here include basic characteristics of FM and sideband, single sideband, bandwidth of the various modulation forms, choice of emission types, briefly talk about amateur satellite operation, operating activities, non-voice and digital communications. On the exam, there'll be one question from each of the subsections. I may not actually cover the questions exactly, although I think I'm pretty close to the order they're listed, but make sure everything sort of is coherent. Topics stick together here. Some quick definitions. AM is amplitude modulation. APRS is short for automatic packet reporting system. ARQ means automatic repeat query. ATV is amateur television. AX.25 packet is a mode of packet communication. I guess I forgot to fill the rest of that in. CW is continuous wave, and DTMF is dual tone multi-frequency. That's the touch tone, like the old touch tone phones of the day. DMR is digital mobile radio. FM frequency modulation. HF short for high frequency. LEO, low Earth orbit. We'll talk about that briefly. LSB is lower sideband. Oops, I missed. PACTOR is a mode of digital communication. Kind of missing a carriage return there, I guess. NTSC is the National Television Systems Committee, and PM is phase modulation. A lot of acronyms, I know. We'll see these later on. PSK is phase shift keying. RF is radio frequency. RTTY, pronounced RTTY, is radio teletype. SSB is single sideband. SSTV is slow scan television, be like faxing. TNC is a terminal node controller, and UHF is ultra high frequency. We will be uploading or making available a PDF of these slides, I believe, afterwards. So. Lastly, upper sideband USB. VHF is very high frequency, and VoIP, VoIP, is voice over internet protocol. And you may even have a VoIP phone and not know it at home. Okay, basic characteristics of single sideband. So let's talk generally about types of emissions. And we've got CW, single sideband, AM and FM, and what those are used for are telegraphy, Morse code for CW. Single sideband AM and FM are used for voice communication or telephony. Slow scan TV / fax is for images. ATV again is images. That's also amateur television. And then the rest of these are data modes. PSK31, RTTY, PACTOR, which has several different versions. And AX25 packet is also a data. And you can see here they vary in bandwidth, how much of the radio frequency spectrum they take up, from very small amount for CW, 10 to 150 hertz, all the way up to things like television, which would be 6 megahertz. So you can see there's a big difference in the bandwidth of these modes, which can be an important consideration. So what kinds of things can you send with these modes? Well, with CW, it's essentially text data. It's letters and numbers you can send. Sideband, AM, and FM, you can send voice transmissions, as I mentioned. Slow scan TV and ATV, that's images. And then we've got text data and binary data. So data modes. Amplitude modulation. The depiction on the top is an unmodulated RF carrier wave. It's just a transmission at a fixed frequency and amplitude or power or volume level, if you want to think of it that way. Once that gets modulated with, for example, a voice, you would get an image that's something like this. If you were to look at it on an oscilloscope, you would see that the carrier wave is modulated with a simple audio tone, looks like a sine wave. That is amplitude modulation. You can see that the signal strength goes up and down as it is modulated for the voice or whatever it's carrying, whatever information is being modulated. So this is, again, a look at an AM signal. You can see that this is looked at again on a spectrum analyzer. You can see that there's that peak in the middle. That's an unmodulated RF carrier. That's the carrier wave. Once you start to modulate the signal, you'll see that it produces a couple of additional peaks on it, like here and here. And those are called sidebands. And these carry the information, the modulated signal, and you can see that it also makes the bandwidth much wider than just the carrier by itself. So with AM, you have that carrier in the middle and you have the two sidebands. Single sideband transmissions filter out both the carrier and one of the sidebands and only transmit the remaining sideband. So instead of sending that entire signal out, what actually gets transmitted is one of the sidebands. In this example, we would call the upper sideband. It's a higher frequency of them. That is called single sideband, and it is probably the most common type of HF voice transmission you will run into in the HF bands. Because it's only transmitting that one sideband, it uses less power, it is more efficient. The signal may not be quite as sharp and clear as an AM signal. Maybe some distortion with that, but it is usually perfectly acceptable. That's AM and single sideband, very briefly. Frequency modulation, instead of imposing that signal that you want to transmit, that information that you want to transmit by changing the amplitude or the strength of the signal, instead you change the frequency. So you modulate the frequency. You can see the top illustration here is what is an unmodulated FM signal. This is just the sine waves of the signal. We superimpose electronically the waveform of the modulated signal. This is what the information we're trying to convey, and you will see that it alters the frequency of that signal. So the modulated carrier deviates the frequency. And sometimes you'll hear people talk about overmodulation or overdeviation on FM. It becomes, that's when the signal becomes too wide and causes the interference with adjacent signals. So that's something to be avoided. Phase modulation is similar to FM, but instead of modifying the frequency, there's a phase. Instead of changing the frequency, there's a change in the phase of the frequency. We're not going to really get into that. That's just a term that you might run into, but not something we need to focus on. All right, so let's talk about what kinds of questions we can expect on these on these topics. Okay, so which of the following is a form of amplitude modulation? So we talked about amplitude modulation, that was AM and single sideband, right? Well, so our choices here are spread spectrum, which we haven't even talked about, packet radio, which is a data form of sending data, single sideband, or phase shift keying. We really haven't talked about phase shift keying. Single sideband is one of those lobes of that signal, and that's the rest is filtered out, and we just send single sideband, but it is a amplitude modulation form. So single sideband is the correct answer there. What type of modulation is commonly used for VHF packet radio transmissions? Well, we talked about sideband and AM being for voice transmission. So really the answer we want to get down to for VHF packet is FM or phase modulation, typically FM for packet radio transmissions. Which type of voice mode is often used for long distance? Oops, I went too far, didn't I? Well, there's the answer. For long distance weak signal contacts, long distance, we talked about HF being sideband. Anytime if you want to think long distance, think sideband. Same with VHF and UHF. You can actually do that on all frequencies, not just HF. Which type of modulation is commonly used for VHF and UHF voice repeaters? Okay, we just said that sideband could be used, but that's not the most common. What did I mention was the most common? Well, it's FM. FM or phase modulation, either of those, typically FM. Okay, so we talked about the bandwidth of the different, briefly in that chart about bandwidth. I'm going to talk a little more about that and choice of emission types. Okay, so once again, looking at the bandwidths. Remember I mentioned that CW had the smallest, and you get on up to fast scan TV or amateur TV, and it's the largest. And you can see this illustrated here on the right. You've got a pretty narrow one for CW. Actually, pretty about equally as almost equally as narrow. That's just an illustration of the different bandwidths. You can see here a 6 megahertz TV channel with a carrier above the lower edge. You can see that there's a fairly wide bandwidth here. In fact, the widest of the modes we've been talking about. Okay. So some of the conventions, things you should note here, that VHF, UHF repeaters and packet radio use FM, as I mentioned before, because of the higher quality of the signal. Remember I mentioned single sideband gets you some distortion. FM will typically be a much clearer signal. Frequencies below 10 megahertz in the HF bands, below 10 megahertz use lower sideband. Frequencies above 10 megahertz use upper sideband. Why? Just historic use. There's not particularly a technical reason for that. It's just how it evolved over time, common usage. I should note that narrower modes require less power to travel long distances. So the narrower the bandwidth, the less power you need. As the narrowest analog voice mode, single sideband is popular for long distance communications. Already mentioned that. And single sideband uses less of the spectrum than the other voice modes. We saw that illustrated. All right, so which of the following types of emissions has the narrowest bandwidth? Well, we know that the really large ones are the TV type ones, but if you think about CW, that's just, the dots and dashes, essentially a tone. That would be the narrowest one. Narrowest bandwidth will be CW. Which sideband is normally used for 10 meter HF, VHF, and UHF single sideband communication? Okay, so we talked about using lower sideband below 10 megahertz and upper sideband above 10 megahertz. So you got to kind of, in your mind, convert, okay, the megahertz to what band would that be in? So
Nấu
you're
cơm hả?
10,
Con cớp.
somebody's not muted. Could you please mute?
Thôi, chị mai chị về không đủ chị tự nấu. Bắt đừng nấu mất công chị la đó.
Could everyone please check that you're muted? Thank you. So both the 10 meter HF, VHF, and UHF are above 10 megahertz. 10 meters in the 30 megahertz range, roughly. And VHF and UHF are above that. So they would be using upper sideband. Your only two choices are upper and lower in this context. Upper and lower, and this would be upper. What is a characteristic of single sideband compared to FM? Well, we certainly know that their single sideband have a narrower bandwidth. The question is, are they less susceptible to interference, or are they more susceptible? Remember, and are they easier to tune correctly? Well, FM signals are on a, the basic answer is it's that they have a narrower bandwidth, because that's what we've been talking about as bandwidth. Actually, sideband signals are actually more difficult to tune in, and they are susceptible to interference. So single sidebands have the narrower bandwidth. Remember, we've been talking about bandwidth, so that's kind of the clue here. What is the approximate bandwidth of a typical single sideband voice signal? We kind of went through that chart pretty quickly, didn't have it up for very long, but it was like 2800 hertz, so it's 3 kilohertz roughly 3 kilohertz. So what is the approximate bandwidth of a VHF repeater FM voice signal? So the question is, what is the bandwidth of your FM signals? And it's around 10 to 15 kilohertz, roughly. So you can see that's quite a bit more. What is the approximate bandwidth of AM fast scan TV? Remember, that was the really wide one, wide bandwidth. It was up at the 6 megahertz, much wider than the other bands, other bandwidths. What is the approximate bandwidth required to transmit a CW signal? This one you're probably just going to have to remember that it's going to be small. It's going to be the smallest one. And in fact, in the answers, it is the smallest answer. It's the 150 hertz. Quite narrow. Which of the following is a disadvantage of FM compared with single sideband? Okay. Mentioned it before that FM would have a better, higher quality signal than single sideband. So we know that FM is not poor, so that also rules out that all of the above answer. So it's either going to be B or C. And we also talked about how sideband signals are harder to tune, so that would not be correct, that FM are harder. And B is only one signal can be received at a time. There's a concept called FM capture on an FM signal, and basically you're only going to hear whatever the strongest signal is. Your receiver will, quote, capture it, and you won't hear other signals. With single sideband, you'll hear overlapping conversations, which you don't get with FM, which is why FM has a better voice quality, but you have that FM capture issue where you're only going to hear the strongest of the signals. All right. So now we're going to touch on amateur satellite operation. I guess since it's a complete change of topic here, I'll pause just briefly if there's any specific questions on what we've covered so far. I know it's a lot of information and you're going to need to go back and look at it, but. All right, well, then let's move on. Some definitions here. Most amateur satellites are in what's LEO. That was one of the acronyms we had, low Earth orbit. They're what they call CubeSats that are about 1 foot on each side cube. They're usually launched as basically as ballast with another payload, so they get a free ride when they get launched, which is kind of a good deal for us as a community. The satellites do have beacons with telemetry data showing, so they can monitor the health of the satellite. And spin fade is a problem caused by antenna misalignment of the satellite. In other words, the satellite's moving through space and it's not steady. It tends to rotate or spin in space, which causes the antennas not to be lined up perfectly all the time. So that you get this fading in and out that happens, called spin fade. They usually do what we call crossband signals. They receive on one band and transmit on another one. So you usually see it abbreviated as like VU, means the uplink is on VHF and then the downlink is on UHF. So you transmit to them on VHF and you would receive back from the satellite on UHF. Satellites may accept or repeat CW, sideband, FM, or packet. They can do all of that. You don't want to use a lot of power when you're transmitting to a satellite because it'll block out other users. So you want to set your power level by listening to the downlink, and it should be about the same volume. So you don't want to be using too much power. You're going to see a question about the term Keplerian data. Keplerian elements are basically bits of information that describe the orbital path of the satellite. And it's what you use to track or predict and know where the satellite is at any point in time. And you can see there's an example at the bottom here of a bunch of numbers that relate to this different parameters of the satellite's motion. Those are referred to as Keplerian elements or Keplerian data. The other thing that happens with a satellite is Doppler shift. Okay, probably remember the term Doppler shift from maybe high school science or whatever. And it's that phenomenon you know about, like if you hear a train whistle, if it's coming towards you, it sounds like it's going up in pitch, and as it's going away, it seems like it's going down in pitch. Well, you get the same sort of effect with the frequency of transmissions from satellites. As they're going towards you, there's a move up in the frequency. As they go away, there's a movement down in the frequency. So it seems like it's changing. I mean, it's fixed from the point of view of the transmitter, but from your point of view, it's changing as it moves through sky. So that's another thing that has to be accounted for when you're trying to transmit to and from a satellite. And this is just a picture of an astronaut operating off the International Space Station. In fact, I think most of the ham, the astronauts are licensed hams, and they maintain ham stations on like the International Space Station, just so they can communicate as part of their public service with anyone that wants to talk to them. All right, so let's look at the satellite related questions. What telemetry information is typically transmitted by a satellite? And we talked about that what it's going to give you in the way of telemetry information is the status and health of the satellite. The way to monitor its performance while it's up there. What is the impact of using excessive effective radiated power on a satellite uplink? Well, you're not going to command the satellite to do something, but you could block the access by other users. you're not going to overload their satellite's batteries, or reboot any computers, but basically you're just going to prevent other users from being able to use it. So as a courtesy, you don't want to be doing that. Which of the following are provided by satellite tracking programs? Didn't really talk about that, but if you're going to be operating with satellites, you're going to need to have some kind of software that's going to assist you in knowing where the satellite is, where to point your antenna, things like that. And they will typically have things like maps showing the real-time position of the satellite track over the Earth. They will have the time and the azimuth and elevation of the start, maximum altitude, and end of a pass, so that you know what the track is when it's going to start, where, what direction it's going to be in, how high it's going to be off the horizon, and so forth. And the apparent frequency of the satellite transmission, including Doppler shift. Talked about how you need to take that into consideration, and your satellite tracking programs will do that for you. So the answer is that basically all of these choices are correct. What mode of transmission is commonly used by amateur radio satellites? This is one of those cases where all of the above is a great answer, because we've mentioned that it does all of these things. It does data, it does CW, FM, sideband, all of the above. And what is a satellite beacon? Well, we talked about that it's what transmits the status information back that we already had one question about. So it is a transmission from the satellite that contains the status information. So which of the following are inputs to a satellite tracking program? The only thing we talked about as being the way to track it was the Keplerian elements, and that is the answer. The other sort of basically red herrings. So Keplerian elements is what we use to track satellites. What is Doppler shift in reference to satellite communications? Remember, it has nothing to do with the orbit, it has to do with the signals. A mode, it's not a mode, it's an observed change. Just like the observed change you have in a train whistle when the train's moving towards you. It's the observed change in signal frequency caused by relative motion between the satellite and the Earth station. Or you're the Earth station, you're the person transmitting from Earth to the satellite. And it's not a special digital communication mode. It's that observed change in signal frequency. Doppler effect. Doppler shift. What is meant by the statement that a satellite is operating in UV mode? Okay, so remember we talked about, we gave the example of VU, which was VHF uplink, UHF downlink. So what would UV mode be? Actually, it would be kind of the opposite of that. The uplink is UHF and the downlink is VHF. And 70 centimeter is a UHF band, 2 meter is a VHF band. So the correct answer is B. It goes up 70 centimeter or UHF and downlink back down in the 2 meter band or VHF. So it's UV as opposed to VU in the earlier example. What causes spin fading of satellite signals? Well, we know it's not Doppler because we talked about that already. Interfering signals. We talked about how that satellite's moving through space and it doesn't stay in a fixed position, how it rotates and that makes the signal fade in and out. So what causes spin fading? The rotation of the satellite and its antennas. What is a LEO satellite? Well, it's not named after the constellation Leo. No, it is a satellite that is in a low Earth orbit. LEO is a low Earth orbit. Who may receive telemetry from a space station? You don't have to have any special credential to do that. You don't have to register with anybody. You don't have to be certified by anybody. Anyone can receive telemetry from the space station. Which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? Well, we talked about you want to make sure that your signal is about the same as the downlink signal that you receive. So that would be the answer C, that your signal strength should be about the same as the beacon. So when you transmit up, when you hear your signal back down, it should be about the same as what you hear the satellite broadcasting on its own, if that makes sense. Remember, we have a beacon transmitting the health of the satellite, status of the satellite out, that whatever the strength of that signal is, when you hear your downlink coming back, it should be the same. If it's louder, then you're using too much power. If it's weaker, you may want to increase. All right. Any questions on that before we move into operating activities? So some additional definitions. Direct radio direction finding is exactly what it sounds like. It's locating the direction that a radio RF signal is coming from. It requires a directional antenna and some sort of meter to measure the strength of the signal so you can tell whether you're pointing in the right direction or not. Contesting, that's a popular activity. It requires, basically it's trying to contact as many stations as possible during a particular time period. And there'll be different criteria. Sometimes in contests, you'll be trying to contact one station in a particular state or on a particular frequency or whatever, particular band. And the skills that are kind of required to do this is basically, this is primarily done in HF. You need to be an efficient operator, and you're only going to transmit minimum information to make that exchange of information that you need to comply with whatever it is you're doing in the contest, and then move on to the next one because you're trying to get as many contacts as possible in the shortest amount of time. So forces you to be pretty efficient in your transmissions. Maidenhead grids. This is just a system, a grid system used for locating positions on Earth. And it's used quite a bit in amateur radio. It's used a lot in some of the digital modes, for example, for locating where different people you're trying to contact are. So basically, the world is divided up into these letter and number combinations. It can either be at least 4-digit location, and typically you go with 6 digits for a more precise area. You got 2 letters and 2 numbers will define an area that's a 1 degree of latitude and 2 degrees of longitude. So here's an example that shows Seattle, which I live near, as being in CN. So you can see it's in the CN and then 87. So that would define this fairly large square here. And then it would be further subdivided with 2 additional letters after that can divide it down even more. So basically, again, the Earth is divided into these squares and subdivided on down. Just a way of identifying a location. Echolink and IRLP. These are 2 different ways of communicating to other stations through repeaters that are connected together by the internet. So with Echolink in particular, you can actually talk to ham radio operators through your computer, and they could be on their radio somewhere, or vice versa. It uses VoIP, voice over internet protocol technology, and That's pretty much what you need to know about it. This is just an illustration of kind of what that's like. You can see that the gateways or repeaters are linked together via the internet. So both of these use DTMF tone. So if you've got your microphone that has the numeric keypad on it, or if you have a handheld radio that has a numeric keypad on it, the tones that are created when you press those keys are what are used to link and unlink the various nodes and connect you through both Echolink and IRLP. IRLP only links repeaters together, but Echolink allows you to contact, as I mentioned before, directly with a computer to the system. You have to be a licensed ham operator to use these, and with Echolink, you have to be registered in their system to use it. Okay, so let's take a look at the relevant exam questions related to this. Which of the following methods is used to locate sources of noise, interference, or jamming? Well, we talked about being able to find a source of a radio transmission, an RF. So that would be a good way to find someone who's jamming or interfering with you. And that would be through radio direction finding, RDF. Which of these items would be useful for a hidden transmitter hunt? So again, you got a signal you're trying to find somewhere. You're going to be basically doing radio direction finding. And we mentioned that we're some things that we needed. And one of those important things would be a directional antenna, like a Yagi or similar directional antenna, because you want to be able to pinpoint the location. If you've got something that's receiving signals equally all around omnidirectionally, you're not going to get an idea where the signal is coming from. That's why you need a directional antenna. What operating activity involves contacting as many stations as possible during a specified period? That was what we were referring to as contesting. Contesting was the answer. Which of the following is good procedure when contacting another station in a radio contest? Well, we said you want to be an efficient operation. You want to, because you're trying to catch as many stations as possible in the shortest amount of time. So you're only going to send the minimum information needed for proper identification and whatever the rules are in that contest. So brevity, minimum information. What is a grid locator? That would be like Maidenhead grid. That would be a letter number designator assigned to a geographic location. And that was the map we looked at. How is over-the-air access to IRLP node accomplished? Remember, we talked about using that keypad on your microphone or on your handheld radio by using DTMF signals. Okay. What is Voice over Internet Protocol? Well, we've sort of briefly touched on that it's a way of having voice communication over the internet. And that is very simply the answer. It's a method of delivering voice communications over the internet using digital techniques. What is the Internet Radio Linking Project, IRLP? Remember, that was similar to Echolink, that it's a way to connect amateur radio systems, such as repeaters, via the internet using VoIP technology. Echolink and IRLP are similar in that way. Which of the following protocols enables an amateur radio station to transmit through a repeater without using a radio to initiate the transmission? And the answer to that would be Echolink. Remember, you said that was the difference between Echolink and IRLP, or one of the differences. What is required before using the Echolink system? You don't have to purchase anything, but you do have to register with them, and you have to be a licensed amateur radio operator. So the answer is C, register your call sign and provide proof of your license. Don't have to pay anything. And what is an amateur radio station that connects other amateur stations to the internet? It's called a gateway. Whether it's an IRLP or an Echolink gateway, they're referred to as gateways. All right. So our final section we'll be covering here is the non-voice and digital communications. We'll talk briefly about APRS, Automatic Packet Reporting System. It's a way of providing real-time location data. APRS radio equipped with APRS will transmit the location of that transmitter. And you can go on, there's places you can go to monitor this. One of them is aprs.fi website. You can also it can also transmit weather data and short messages to others who are so equipped with APRS. PSK31 is a digital mode. It's low speed, narrow bandwidth data mode. It's very efficient. It's basically texting if you want. It's keyboard to keyboard. It uses phase shift keying, but it does not have any error correction like some other digital modes. That's PSK31. NTSC, National Television System Committee. It's analog television standards that are commonly used in the US and a few other countries. There are several other versions of television standards that are used in other parts of the world. In the US, we use NTSC. WSJT, which is short for Weak Signal Joe Taylor, who invented it. And these are some of the WSJT type modes, FSK, a couple of JT modes. FT8 is probably the most popular of the digital modes these days. That's one you'll hear a lot about is FT8. Digital mobile radio is an open digital standard. It's a sort of a new technology of digital radio. It uses time division, multiple access technology to create two channels on the same frequency. They're split in time. So it's digital signal that's split into tiny little time periods of signal, on and off, on and off, on and off. And one signal's on when the other one's off. So you can have two conversations essentially going on at the same time on the same frequency with this technology. It's becoming much more popular. Packet radio is a way of sending data over the radio, like email type of thing, using a terminal node controller. They can either be a hardware TNC or a software TNC through your computer and your radio. Data is what they call packetized with a header and an error checksum so that it is error free. It requires retransmissions if it doesn't get the correct full packet. They're automatically identified and with what we refer to as automatic repeat query, ARQ. It'll once it's gone through, it has gone through without any errors. High-speed data, packet radio is generally at 1200 baud, maybe 9600 occasionally. Most around, depends on what's available in your location. There's also high-speed broadband hamnet, like our hamLAN we have here in the Puget Sound area. High-speed multimedia data network. It's like a mesh network, similar to that. And it's a way to transmit high-speed data in the microwave range, as we're talking about 5 gigahertz for the frequencies. Electronic keyer is something that converts Morse code transmissions electronically. It makes for a uniform type of signal. CW is still alive and well. All right, we're kind of running short on time here, so we're going to get through these questions real quick. Which of the following is a digital communications mode? We mentioned at least a couple of these for sure. And then all of them are actually correct. JT65 is one of the WSJT modes, packet radio we were just talking about. And IEEE 802.11 is another digital mode. What is a talk group on a DMR repeater? We didn't talk about that, but what it is, it's a way for groups of users to share a channel at different times without hearing the other users on the channel. It's a way of selectively eliminating other users. You transmit in a talk group. So it's a way for users to share a channel at different times. It's a DMR concept. What kind of data can be transmitted by APRS? Remember, we talked about all of these things. The answer is all of the above. Your position, your GPS position, some texting, limited texting, and some weather data. What type of transmission is indicated by the term NTSC? That is television, analog, fast scan, color TV signal. That is the US protocol for television. Which of the following is an application of APRS? Well, if you think about what it does, it can provide real-time tactical digital communications with a map showing where the stations are. Remember, it transmits their locations. So that is what it's a good application of APRS, is to provide real-time tactical digital data information. You can map people out with it. What does PSK mean? We briefly touched on that. Phase shift keying. PSK is short for phase shift keying. Which of the following describes DMR? Remember, I mentioned it's a way for time multiplexing two signals at the same time on a single repeater channel. So you can have two conversations going at the same time on that frequency. Which of the following is included in packet radio transmission? We talked about it had a checksum to permit error detection and a header that has the call sign and an automatic repeat request in case of error. So you can have error-free transmissions. So it's actually all of the above. It's the correct answer. What is CW? That is another name for Morse code, continuous wave transmission or Morse code. Which of the following operating activities is supported by digital mode software in the WSJT? Actually, these were all, there were various modes. All of these are part of that package. Earth, moon, earth, weak signal propagation, and meteor scatter. What is an ARQ transmission system? Remember, we talked about automatic repeat query. It's an error correction method in which receiving station detects the errors and sends a request for retransmission. Automatic repeat query. So it's a retransmission to make sure you got it the correct data. Which of the following best describes an amateur radio mesh network? Talked about it's a data network. In this case, mesh is one that uses commercial Wi-Fi equipment. We talked about the HamLAN and similar networks. What is FT8? It's one of the digital modes we talked about on low or weak signal or low signal to noise ratio, WSJT modes. So it's a weak signal digital mode. A lot of information, short amount of time. Any questions? We've got just about a minute or two. We can handle any questions you've got. Going once. Going twice. Either answered all the questions or everyone's asleep, one or the other. But either way, we're going to be wrapping up. That's all, folks. Let me stop sharing, or let me close out of this.